Okay, pre-calc students, welcome to the introduction to your investigation. What we're going to be investigating is limiting arguments and derivatives by first principles. And so the objective of this investigation and of this video specifically is to help you to make the connection between limiting arguments that we were dealing with in the previous unit to finding slope functions by first principles. So first I'm going to take you back to last unit. You may specifically remember this example. We did it in unit 6 where we were asked to evaluate the limit as h approaches 0 of f of x plus h minus f of x over h, where we were given the function f of x as 4 over x. And so what I'm going to do first of all is take you through this specific example just to remind you of how we compose and a couple of other important skills when we evaluate limits, and then I'm going to connect it to your investigation. Okay, so first things first, what you've been asked to do in this particular case is to evaluate the limit. To do so, we need to find an expression for f of x plus h, and so that's an instruction to substitute into the f of x equation the expression x plus h in the place of x. And so into the f of x equation, wherever we see an x, we are going to replace that with x plus h, and that will yield f of x plus h. Okay, and so we're going to say the limit of h approaches 0 of, and so my first term is going to be f of x plus h, which is 4 over, and in the place of x, I'm going to substitute in x plus h minus the f of x equation, which is just 4 over x, and that is divided by h. And so I've made my substitution. If I want to go ahead and evaluate the limit at this point, if I do so by direct substitution, you can see immediately we have a problem because we have a 0 denominator. And so all that's going to yield is that the limit does not exist. And so we need to test first to see if there's an appropriate algebra method that we can use to simplify the expression, which will allow us to evaluate it. Okay, and so obviously what we're looking to see is if the function maybe has a hole, and we're trying to see if we can cancel that out so we can evaluate the slope. Okay. So what I'm going to do in this case is I'm going to use one of the algebra techniques, and so one of them was factoring and cancelling. There's no obvious factoring and cancelling. The second was to use a conjugate. Typically we're going to use a conjugate in the instance where we've got square roots, and then we've got this, which is our third kind of algebra problem, which is a complex fraction, adding and subtracting fractions on top of other fractions. And so what we're going to do is look at each of the denominators for the 3 terms. We're going to find the lowest common denominator for all of those terms, which in this particular case is x multiplied by x plus h. And we're going to multiply the entire expression by x times x plus h over itself, which is the same as multiplying by the numerical value 1, which does not change the value of the expression at all, which we're not allowed to do, of course, because it's not an equation. Okay, and so now I'm going to move to the next line, the limit as h approaches 0, and what I'm doing is I'm distributing the numerator to the top of our complex fraction and the denominator to the bottom of our complex fraction. Actually, let me just give myself a little more space over there. And so in the denominator, I'm going to have h multiplied by x multiplied by x plus h, and then in the numerator I'm going to distribute first term multiplied by my factor, and then the second term as well. And so I'm going to simplify to get 4x, because the x plus h's will cancel, minus 4 multiplied by x plus h. Okay, I'm going to move over to the right hand side of the box here, do a little bit more simplifying. So the limit as h approaches 0, and then do a little more distribution in here. So distribute out the 4, and I'm going to get 4x minus 4x minus 4h in the numerator. in the denominator. I'm going to leave it as is for now. Do a little more simplifying. So 4x minus 4x is obviously going to cancel out. I'm now left with minus 4h in the numerator, and so I can cancel the h's as well. And then I can finally find the value of this expression. And so if we look over there, we are left with minus 4. So let me rewrite it one more time just so that it's clear. We have the limit as h approaches 0 of minus 4 over x multiplied by x plus h. As h approaches 0, the value of this term will approach 0, and I can evaluate my limit as minus 4 over x squared. And so that is the answer to the limit of f of x plus h minus f of x over h, where f of x is 4 over x. And what you'll see is that the limit in this particular case is itself a function. Okay, and this is going to be important because we're now going to connect this to what we've actually found. What you've actually found in this case is the first derivative of the function f of x equals 4 over x, also known as the slope function. Okay, so keep that in mind. Let's go to the graph over here. We are going to try to explain why it is that you've just found that. Okay, so now we're talking in general terms. If I have any curve in the form y equals f of x, a non-linear curve, well, obviously linear functions are not curves, but if I have a non-linear function, then what I'm going to do is I'm going to mark point A on the function, and I'm going to give A the coordinates x, f of x. And so I'm choosing some x value which, substituted in to the f of x equation, will yield the y value f of x. I then mark a second point on the function, point B, and for its coordinates I'm going to say x plus h, where h represents the distance between these 2 points, x and x plus h, and that will yield a corresponding y value of f of x plus h. Okay, so if I substitute in this value x plus h, where x and h in this particular case are being represented by positive numerical values, positive real numbers, then I'm going to get the corresponding y value f of x plus h. What I'm basically going to do now is, if I were to join those 2 points, they would be joined with something called a chord or a secant. Let's pretend that that's a line. And if you were to use the slope function, the slope formula, you could calculate the slope of segment AB, or chord AB, or secant AB, just using the slope formula, which is of course y2 minus y1 over x2 minus x1. And so here is our y coordinate. Like I mentioned, the coordinates of B are x plus h is the x value, the corresponding y value is f of x plus h, and so this is y2, this is y1, so y2 minus y1, or y1 minus y2, doesn't really matter, y2 minus y1 over x2 minus x1, and I'm saying x2 is the x coordinate of point B, x1 is the x coordinate of point A, and what I'm going to end up with is the expression f of x plus h minus f of x over h, after we do a little bit of simplifying in the denominator. And so what you should be able to see, of course, is that that is the exact same expression that for which I evaluated the limit as h approaches 0. Okay, and so if you come back down here, then the last piece is just to connect this to the idea of slope. And so right now, what AB is going to do is give us the average slope between points A and B, and what we're actually interested in doing is finding the exact slope of the function y equals f of x at point A. And so what we can do is, if we were to take B and move B progressively closer to point A, what would effectively be happening is that the h value would be reduced. And so as we reduce the h value, which is this part over here, as h approaches 0, the slope of the secant will approach the slope of something called a tangent. And so what a tangent is a tangent is a line segment which is going to intersect the graph at exactly one point, and that point is going to be point A in this case, because we're looking for the slope at point A. The slope of the tangent at point A is the limiting value of the slope function for chord AB. In other words, the limit as h approaches 0 of the expression f of x plus h minus f of x over h, which is the slope formula for AB. As h approaches 0, in other words, as b gets infinitely close to a, this will yield the slope of the tangent line at point A. When we do the slope of the tangent at point A in general form, as we did in this example over here, then what the formula yields, or what the limit yields, is in fact the slope function, which means it yields a function which, for each different x value substituted in, will give you a slope of the tangent for the given curve f of x, which effectively means you could then use that function to evaluate the slope of any tangent at any point along the curve y equals f of x, once you've established what the limiting value is of f of x plus h minus f of x over h as h approaches 0. Okay, and so what this is, as I mentioned before, is the slope function, and as you'll see detailed here, what that allows us to do is to find the slope of the tangent at any point on the graph f of x plus h by substituting in different x values. What this also yields, or what in this particular case minus 4 over x squared is the first derivative, and so that is denoted f dash x, and the first derivative is the slope function, and that is used to evaluate slopes of functions at any given point on the function. What we are doing through this process is we are finding the first derivative using first principles, and that's the essence of what you need to do in your investigation. Good luck.